Not finished yet, ma'am.
Not finished? Up
Yeah,
to
we
which
have
section you study? So did you know the terms field capacity, permanent melting point, all these things? Did you study?
No, ma'am.
Okay. I think you will study in your coming lectures, right? So what did you study? In soil water content, no soil water.
methods of
Methods for? What? Okay, so what is the composition of soil water? Composition? Normally, what is the range of water or moisture that is found in the soil? In the volumetric composition of soil, you all studied, no?
25%.
Yeah, 25%. Soil, yeah, that also 25%. Okay, so that means that range will change. Okay, so within, if the soil is saturated, so what is the percentage of water, soil water? So what do you mean by saturation?
all pores are filled with water.
Okay, that means all the macro and the macro pores are filled with water. So that time, the soil, we can call it as it is in saturation. Okay, so that time the percentage it changed to 50%. Right? Okay, so these are some basic things, and you will study all the things: this field capacity, permanent melting point, and all these available water, gravitational water, capillary water. All these things you will study in your theory part, right? Okay, so don't worry about that one. Here, just you're going to draw a graph against the metric potential and soil moisture content. Okay, so we can tell a definition for metric suction as it is the energy state of soil water. Okay, so it is a basic energy of the soil water. Okay, so which is related to the capillarity and adsorption forces. Okay, so using these two data, soil moisture content and the metric suction, we are going to draw a graph. So we can call it that graph as soil moisture characteristic curve or soil moisture retention curve. Okay. Did you understand that one? Both are same. Soil moisture retention curve and the soil moisture characteristic curve, both are same, right? Okay. Okay, so why we need to do this one? So why we need to know this relationship between the soil moisture content and the metric suction? Why we need to know the soil moisture content? Can you answer me that one? For each and every practical, there is a purpose, no? So why we need to study this one? Why we need to know the soil water content or soil moisture content? Just the basic thing.
Crops need water. The availability of water in the soil.
Sorry, can you please tell me again? I couldn't clearly hear you.
Availability of water in the soil to get the crop getting the water.
Okay.
So we need to know the soil moisture.
Okay, so you have to know the availability of water that is available to the crop, right? So with that, you can plan the irrigation schedules. Okay, so if it is the soil is in saturation condition, you no need to irrigate the soil. No? So likewise, you can plan the irrigation using this soil moisture content or soil available water. Okay, so that is the basic purpose of to find out this soil moisture or the available water. Okay, right. So these theory sections you will study in your theory part. Okay. Yes, here I mentioned some key points about this desorption and adsorption. Okay. This relationship can be obtained first by saturating the sample. Okay. So when you saturate a soil, you can observe one thing. Okay. If you saturate the soil, what will happen? What will happen to the soil? Or what will happen to the pores? The volume of soil will increase, no? Because all the pores will absorb the water. Am I correct? Yes or no? If you irrigate the soil, what will happen?
One increases.
Okay, that means water get into the pores, right? Here we are telling a desorption curve and adsorption curve. You can see this graph is drawn against the water content and metric suction. Okay, so when you're drying the soil, what will happen to the soil? You can observe, and then you wet the soil, what will happen? Okay, so these things we are call it as the desorption curve and adsorption curve. Okay, so if you study the theory part only, you will understand. Okay, so I just introduce these terms: desorption curve and adsorption curve. Okay, so when you are drying the soil, you can observe this desorption curve. Okay, so that means the water content here is decreasing. That aromas show all these things. Right, so I don't tell it further because you will study these things in your theory part. Right, and you have to know what is hysteresis. Okay, so this is a basic difference between this desorption curve and adsorption curve. We can call it as hysteresis. Okay, I just introduce these terms to you. Okay, so don't worry, you will study these things in your theory part. Okay, so no need to confuse about these terms. Okay, Okay. So here the objective of this practical is to determine the soil water retention relationship within the lower suction rate. That means just you have to know the relationship between the metric potential of water and soil water content of the soil. Right? So that is the main objective of this practical. Right, so let's we see the procedure. Before see the procedure, I will show a video. Okay, so that will be easy to understand. Okay, so I will show a similar procedure video, right?
Recording stopped.
Sorry for the inconvenience. Please wait for 5 minutes, right? Can you hear me?
Yes, yes.
Okay, so there's a connection issue here. Okay, so wait for 5 minutes, okay?
So can you hear me?
Yes, ma'am.
Okay. Okay, sorry for the inconvenience. Okay, so there is a connection issue here. Okay. So can you able to see the video?
No, ma'am.
Oh, wait. Okay, I couldn't share that video. Okay, I will try again. Now, can you able to see the video?
Yes, ma'am.
Okay, so this is the setup that is we are going to use to find out this soil moisture relationship. Okay, so that is this one we are calling as the hanging water color. Okay, so this is burette and this one Buchner funnel, and just we are going to connect that one using a plastic pipe. Okay, so this one called it as the hanging water color. Okay, so you can observe the procedure, and I will ask one person to tell the procedure, okay, what they are doing. Okay, so carefully observe the procedure. Okay, we are transferring the distilled water to the burette. Okay, you can observe they can move that burette upward and downward. Okay, you can observe this Buchner funnel and the setup. Okay, so likewise, you have to set up the column, hanging motor column. Okay, so then observe. Okay, so you can adjust the water column to intake or remove the water. Okay, so you can adjust the water column of that burette height. With that, the water will getting in or it will remove. Okay, so you can adjust the height. Okay. So you can observe now the water is inside the Kushner funnel. Okay, here they are taking some sample, and in our normally in our practical we are using a sandy soil. Okay, so the first procedure you have to use the hanging water column, and then you have to place the filter paper. Then after you have to check the air leaks. When you are connecting the tubes to the water column and the Buchner funnel, there may be some air leaks. So we have to remove if any air leaks is present, we have to remove that one. You all can see this video, right?
Yes, ma'am.
Okay. Okay, so after checking for the air leakage, we can transfer the soil sample to the Buchner funnel. Okay, so here they are transferring some amount of sample, but in our procedure we have to wait around 200 gram of sandy soil. Okay, just we have to take 200 gram of sandy soil in a beaker, and the sandy soil that should not have any water. Okay, so that means we are not taking a saturated soil, we're just taking a dry soil. Okay, that is free from moisture. Okay, for from that we have to transfer some amount of sandy soil to the Buchner funnel like this. Okay, so then you can observe. Okay, so they are mentioning about 50 gram, but here in our procedure we will get that weight after some procedures, right? So I will tell that part later. Okay, so you can now observe this one is the dry soil. Okay, so when you adjust this water column, you can observe it will become saturate. Okay, so when you move the soil column, you can observe that one. Okay, so carefully observe. Okay, so can you observe the soil is become saturate. Okay, so when you rise the water column upward, soil become saturate. Okay, so that means we are changing, when we are changing the metric potential here using this water column, the soil water, and this water is enter into this soil. Okay. Okay, so then observe that. Okay, so now you can see the whole soil is saturated with water. Okay. Okay, so here they are mentioning as the stop of that one. Normally we are choosing one that screw like setup in the burette. No? That's that setup they are calling as stop cop. Okay, so carefully observe how they are taking the reading. Okay, so you have to record the distance from the datum level to the center of the soil sample. That means you have to take the height, okay, with the center of the Buchner funnel. Here just we are taking the heights. Okay. Okay, here in the burette, you can get the volume of water and then you can measure the height. Okay, so when you are changing the that water level height, what you can observe. Okay, so we can change the water column height and we can get other readings also. To draw a graph, we need so many readings now. So we have to repeat the steps. So we have lowered the burette about 2 centimeter. Okay, so we can adjust it to 2 to 5 centimeter. Okay, so carefully observe how they are taking the readings. Okay, so now they are taking the weight of the soil sample. Okay, for that we can't take that weight directly, no. Okay, for that they have to measure the diameters. Okay, diameter of the funnel and height of the funnel, that Buchner funnel. Okay, so they are going to measure that one. Okay. So I hope you got an idea about the procedure, right?
Yes,
Okay, about the setup, all these things, I hope. I will share that video link. You can go through that one. Okay, okay, okay. So can anyone read the procedure now? Can you able to see the slide? Is it visible?
Yes.
Okay. So can you tell the procedure or read the procedure? Okay, so for this you have to use a hanging watercolor setup. Okay, with a Bushnell funnel. Right. For first step, you have to place a filter paper within the Bushnell funnel. You have to place the Bushnell funnel, and like they showed in the video, you have to move the burette up and down, and you have to check for the air leaks. Okay, and also you can observe any water leaks. You have to get over it. Okay, so by placing proper tubes, you have to check all the connection using a filter paper, right? So after that, you have to place a membrane filter. I think in the video, it is in light blue color. Okay, so you have to place that one after keeping the filter paper. Okay, so then after that, you have to transfer some amount of soil. Okay, from 200 gram of sand, you have to transfer some amount of soil into the Kushner funnel. Okay, so the soil should be dry in condition. Okay, up to this, do you all understand?
Yes.
Okay. Okay, so here you can see that procedure. Add some of the sand to the funnel and rise the water level to wet the sample. Okay, so when you rise that water column, the water will get into the soil. Okay, I hope you already saw in the video. Okay, so when you're rising that water column, some amount of water that will enter into the soil. Okay, that one you observed in the video, no?
Yes.
Okay. Okay, so then add enough sand to fill the funnel. Okay, so you have to, I think they take another soil sample. Here, usually in our practical, we are using the sandy soil because it has more macro proportional. So the water will get into that soil very fastly. So you can observe the water entering or the saturation clearly. Right? Okay, so that's why we are using the sandy soil. Okay.
Okay.
Okay. Okay. So then you have to weigh the remaining sand that is present in the beaker. Okay, after transfer some amount of that sandy soil to the Bushner funnel, you have to weigh the remaining soil. Okay, initially you took 200 gram of soil in the beaker, right? Then after you transfer some amount of soil into the Bushner funnel, and finally after the transferring, you have to measure the remaining sandy soil that is present in that 500 milliliter beaker. Okay, so that is we can call it as the loss of weight. Okay, so that loss of weight is equal to the soil in the funnel. Okay, so did you understand that one? We already took 200 gram of soil and we transfer some amount of sample into the Buchner funnel. Okay, so now we are going to measure that remaining amount of sandy soil. Okay.
Okay.
Okay. Okay, so then after you have to lower the water level into the bureau to be level with middle of the sand sample to saturate. Okay, so I already told we have to we can move that water column. Okay, so we have to keep that burette level with the middle of the sand sample to saturate that sandy soil. Okay, so we have to saturate the sample very slowly to reduce the entrapment of air. Okay, so we have to carefully adjust the that watercolor. Okay, so here they have mentioned the water level in the burette should be near the halfway mark. That means 30 milliliter to read from the scale. Okay, at that time you have to note the burette reading. Okay, so through the burette reading you can get the volume. Okay, and you can measure the height. Okay, from the height you can get the matrix section of that soil. Okay, so did you understand that one? Just you have to move up and down to saturate the soil. Okay.
Okay, ma'am.
Okay. Okay. So then they mention to lower the burette by 2 centimeter and allow it to come to equilibrium. You know, after some point, after saturation, the reading will not change. Okay, am I correct? If the soil is saturated, all the pores are filled with water, so the soil will not get into the, sorry, water will not get into the soil. Right? Is it okay?
Yes.
Okay, so that times we have to take the reading. Okay, so measure the distance between the sand sample and the water level. Okay, so that one we call it H1. Okay, so this shows the imposed suction on the sand sample in centimeter. Okay, so we can directly measure the height and we can tell it as the matrix suction. Okay, so that is the energy state of the water. Okay, so then after you have to note the burette reading. Okay, so that one V2. Okay, so earlier you got one reading. Okay, at saturation. Then after that, you have to get the volume reading in the equilibrium. Okay, so you will get the amount of water that is drained at this suction. Okay, so when you deduct the V1 from V2, you will get the amount of water that is drained at this suction. Okay. So up to this, you understand that one, that procedure?
Yes.
Okay. So then after, you have to do it again and again. Okay, so keep on lowering the burette by 5 to 10 centimeter until you reach 50 centimeter suction level. Okay, so suction level means 50 centimeter height. Okay, so once the equilibrium is reached, measure the distance between the water level in the burette and the middle of the soil sample. Okay, so you have to measure the height between the middle of the soil sample and the burette reading. Okay, so I hope you all observe that when they are taking the reading. Right? Okay. So if you are not understand the procedure, I will share the video link. So please go through that one. Okay, so then only you will get a clear understanding about the procedure. Okay, so then after that, final step mark the top level of the soil sample on the funnel. Okay, so then you have to remove the sand and then you have to measure the volume from bottom of the funnel to the mark, which is the volume of the total sample. Okay, so you have to remove all the soil and then after you have to get one reading. Okay. So previous steps, did you understand? Did you understand the procedure? Yes or no?
Yes, ma'am.
Okay. So then after you have to use some data to calculate the bulk density. Okay. So here I mentioned the equation. Okay.
Okay, ma'am.
Okay. So here they mention how to find out the volumetric water content of the soil, and then after you have to draw the graph against the suction and volumetric water content of the soil. Okay, so I will tell about the calculation part. Okay, so from that also you can understand the procedure, right? Okay, so here likewise you have to get the reading. Okay, matrix section that is measured in centimeter. Okay, so that is the height. Okay, and the reduction of burette level. Okay, so when you are adjusting the burette level, here you have to take the readings. Okay, so at 0 level, what is the volume, and then 5 centimeter level, what is the volume of the burette? Likewise, you have to take. Okay, so all these readings I will give, you have to do the calculation. Okay, so I will give the readings for matrix suction, reduction in burette level, and the burette reading at saturation and reading at equilibrium. Okay, so then after you have to calculate the volume drain, and you have to find out the volumetric moisture content. So what is the equation to find out the volumetric water content of soil? Any idea? Equation? You already studied, no? Volumetric moisture content. What is the equation? Any one of you?
Volume of water over volume of soil.
Okay, volume of moisture content over volume of soil. Okay. Okay, good. So that means you have to find out the moisture content. Okay, so that is the ratio between the volume of moisture and volume of soil. Okay, so then you can find out the volume drain using this equation. Burette reading at saturation minus reading at equilibrium. Okay, so you can find out that one. Okay, so I will show how to find. I will give all the things to you. You can get from this slide. Okay, so no need to worry. Okay, so here I gave the readings to find out the amount of soil. Okay, so diameter of Buchner funnel is 6.5 centimeter, and height of the funnel is 2.5 centimeter, and weight of aluminum cup is 6.159, and remaining salt plus aluminum cup, that means moisture can or any other containers. Okay, that's why here I mentioned as aluminum cup. Okay, so that one 91.752 gram. Okay, so with that you can find out the volume of soil now using these two datas. Okay, so how will you find out this volume of soil? Any idea? I already told we initially we took 200 gram of sandy soil, and we transfer some amount of soil to the Buchner funnel. Okay, so we are giving the data of Bushner funnel, diameter of Bushner funnel and height of the Bushner funnel. Okay, so we already filled the Bushner funnel with soil. Okay, so we can assume that volume of Bushner funnel is equal to the volume of soil. Right?
Okay, ma'am.
Okay, so we can get that one using this data. How will you find the volume of soil? What is the equation to find a volume? Volume of the cylinder. Because you can observe that the Bushner funnel is like a cylinder, that top part. That is in the previous practical, right? You all know the Bushner funnel now? The
Yes.
top part looks like a cylinder, no? So you have to apply the equation of what? Cylinder. Volume of
Pi
cylinder.
squared into H.
Yeah, pi r squared into h. So using that equation, you can find out the volume of soil. Okay. So did you all understand that one?
Yes, ma'am.
Yes,
First
ma'am.
step finish. Calculate the volume of soil. So you can answer for that question. Okay, so then you have to find out the bulk density. Right? So you have to calculate the bulk density of the given soil. So can you able to calculate the bulk density? What is the equation for bulk density? Mass of soil solid over volume of soil. Am I correct?
Yes, ma'am.
Okay, so for that, you have to find the mass of soil solid. Okay, so how will you find that one? Mass of soil solid. You don't know, no? How much of samples you taken in that Bushner funnel? Now you only find out the volume of soil. Okay, so for bulk density calculation, you have to know the mass of soil solid. So how will you find out? You already know the initial amount, right? What is that? Mass of soil initially taken.
200 grams.
Okay, 200 grams. Here, now the data is given for the weight of remaining soil, 91.752. Okay, so you have to find out the weight of remaining soil by reducing 6.159 gram from 91.752. Right, from that you can get the weight of remaining soil. Okay, is it okay?
Yeah.
Okay, so when you're reducing this remaining soil from mass of soil solid, you can get, sorry, 200 gram, you can get the mass of soil solid. Okay, so here to do the bulk density, you need the mass of soil solid. Okay, so you can see the calculation. Here I already give the answers for all these things. Okay. Okay, so remaining soil weight, you have to reduce the crucible weight, 6.5159. Okay, so from that you will get the answer for remaining soil weight. Okay, so then you have to calculate this, reduct this remaining soil weight from 200 grams. Okay, so from that you can get the mass of soil that is in the funnel. Okay, did you understand that one?
Yes, ma'am.
Okay, so using this data, you already know the volume of the soil, and now you know the mass of the soil solid. So from that, you can find out the bulk density of the soil. Okay.
Okay, ma'am.
Okay, so I think these units are wrong. Gram centimeter minus 3, right? 1.378 gram centimeter minus 3. Okay, so up to this, are you clear about the calculation?
Yes, ma'am.
Okay. So then after they are asking the porosity. Okay, so these are the extra things we are calculating. Okay, so you have to find out the porosity. So what is the equation for porosity? You already know the bulk density, right? So how will you find out the porosity? Porosity is equal to 1 minus bulk density over particle density. Okay, so I didn't mention that particle density before. I gave as 2.65. Okay, so you already calculate the bulk density as 1.378, and here I will give the reading for particle density as 2.65. Okay, so from that you can calculate the porosity of the soil. Okay, so that is here as 0.48. Okay.
Okay.
Okay. Okay. Okay. So with the porosity data, we can find out the water content of soil at saturation. Okay. So you all know that another equation for porosity. Okay. Volume of air plus volume of water that is divided by total volume of soil. Okay. So this equation you already know, no?
Yes, ma'am.
Yes, no?
Yes, ma'am.
Okay. So you can find out the water content using this porosity data at saturation. Okay, so you already know in the saturation condition, all the soil pores will fill with the water. Okay, so that means this, this VA plus V volume of water, all are volume of water. Okay, so that means there will be no air in the soil. Okay, so using this data, you can find out the water content at saturation. Okay, so are you clear about this step?
Yes, ma'am.
Okay, so with that, we can calculate the volumetric moisture content. Okay, so you already know the equation, right? Volume of soil moisture, volume of soil moisture over volume of the soil. Okay, so you already calculate the volume of soil here, and then you calculate the water content at saturation, right? 39.835. Okay, and then you can simply divide it by the volume of soil, and you will get one answer. Okay, 0.479. So this is the volumetric moisture content at saturation. Okay, so are you all clear about this?
Yes, ma'am.
Okay. So here you no need to worry about the calculation. Here I already gave the answers to you. Please cross check the answers. Okay. Okay, so there may be some changes. Okay, so if there are any changes, please let me know, right? Okay. Okay, so now you got the answer for volumetric moisture content. Okay, here for the first reading, you will get the volumetric moisture content 0.479. Okay, so likewise you have to do for the other samples. Okay, so I already give all the readings to you. Okay, so using this data, you can draw a graph. Okay, so that graph we can call it as the moisture retention curve. Okay. Okay, so you can use this data directly to draw this graph. Okay, so like this, you will get a curve. Okay, so you have to draw against the metric potential or matrix action against moisture content. Okay, in x-axis, you have to place the matrix action, and in y-axis, you have to place the moisture content. Okay, so you have to draw a graph using these data. Okay. Did you
Okay.
understand the calculation part?
Yes, ma'am.
Okay, so these are the things you have to refer. Okay, all these are the definitions you have to refer and you have to include in your discussion part. Okay?
Okay, ma'am.
Okay. So do you have any doubts? I will share the links. Okay, I will share the video link so you can go through that video. So that will be easier to understand this one, right? Okay, so then you can copy down all these data and you have to draw the graph, okay? Yes or no?
Yes, ma'am.
Yes, ma'am.
Okay. So if you have any doubts, you can ask, otherwise you can leave.
Thank you. Thank you,
Okay,
ma'am.
thank you for your attention.
Thank
Thank you, ma'am.
you, ma'am.